Question 6. Without using mathematical tables or calculator, evaluate cos 135 degrees minus sine 30 degrees divided by sine 135 degrees plus sine 30 degrees. 3 marks. What prior knowledge do you need to have to be in a position to answer such a question and many more of that nature? You need to have the knowledge of the unit circle from trigonometry. And for the unit circle, you have to remember the word cast. And this will help you to summarize about what is involved with sine, cosine, and tangent. So the letter A here represents all. So here we are dealing with theta. And so sine, cosine, and tangent is positive. That's why we say here that all represents sine, cosine, and tangent to be positive in the first quadrant. So this is the first quadrant. Now in the second quadrant, sine is the one that is positive only. So the cosine of an angle between 90 and 180 will be negative, and also the tangent between 90 and 180 will also be negative. So to capture that angle here, we will consider 180 degrees to subtract theta, and theta will present an angle that is more than 90 and less than 180. And then for the third quadrant here, it is the tangent that is positive. So here the sine and the cosine is negative. And so for an angle that is between 180 and 270, to pick that angle, we are going to consider theta to subtract 180 degrees. And then in the fourth quadrant here, the cosine, C represents the cosine. The cosine of an angle that is between 270 and 360 degrees is the one that is positive. So that means the sine of an angle in this quadrant or the tangent of an angle in this quadrant will all be negative. And to consider that angle in the fourth quadrant, you're going to take 360 degrees to subtract theta. And theta will represent the angle that is between 270 and 360 degrees. You also need to have the knowledge of special angles, and this represents the angle of 30 degrees, 45 degrees, and 60 degrees. Now, for the angle 30 degrees and 60 degrees, we normally find it by considering an equilateral triangle here, where its angles are 60 degrees each. And this equilateral triangle, we are going to assume that the sides will be 2 units each. And therefore, we are going to divide this triangle by height here into 2 equal parts, so that we are in a position to pick one of these triangles which will be right. So the base of this triangle, which now I will transfer to this other part, the base here will be 1, and then of course the hypotenuse will remain to be 2, and this angle here will be 60 degrees, and the angle that will be formed here will be 30 degrees, since the height for an equilateral triangle will bisect the angle here. And therefore, to consider the height now of this right angle triangle, we are going to use the Pythagoras relationship, where we know that c squared, that means the hypotenuse squared, will be equal to the base squared and the height squared here added together. So therefore, my height h should be equal to, that is c squared to subtract a squared so that I get b squared. So the height will be the square root of 4 minus 1, which is simply root 3. Now I've got a right angle triangle where I've captured all the angles and all the sides have also been represented. Now I can use this information here to come up with the sine, cosine and tangent of these angles. So we'll begin by the sine of angle 30 degrees. So for this angle here, we know that in a right angle triangle, the angle will be formed by a line that is adjacent to that angle and another line which will be the hypotenuse. So for this angle, which is 30 degrees here, the height is its adjacent, and therefore when you're considering sine using the simplified way, we talk of SOHCAHTOA. We know that sine will be equal to opposite of a hypotenuse. So the sine of angle 30, since this is its adjacent, therefore the line on this other side will have to be its opposite. So it will simply be 1 over 2. That means opposite over hypotenuse. And then the cosine of the same angle will be adjacent over hypotenuse, so that will be root 3 over 2. And then the tangent of the same angle will be opposite over adjacent, so the opposite is 1, and then the adjacent is root 3. And then what about the sine of angle 60 degrees? So for this angle, this line here is its adjacent, so I'm going to consider the opposite over the hypotenuse. So the opposite will be root 3 and the hypotenuse is 2. And then for the cosine of this angle, the adjacent is 1 and the hypotenuse is 2. And then the tangent of this angle will simply be root 3, or you can also write it as root 3 over 1, but it's unnecessary. So that is how you come up with the sine, cosine and tangents of angle 30 degrees and 60 degrees. What about the angle 45 degrees? Here we are going to consider straight away a right angle triangle whose base is 1 unit and height is 1 unit. And therefore, by using the Pythagoras relationship, where we say that c squared is equal to a squared plus b squared, 1 squared plus 1 squared, that is 2, and therefore the hypotenuse here will be root 2. And remember, the angles here are 45, so it means we are dealing with a special right angle triangle, since it is also isosceles, meaning that these two lines here are equal. And therefore, now that we've represented all the sides and all the angles of this right angle triangle, we can pick the information we want. So we'll say here that sine of angle 45 will be equal to the opposite of adjacent, which is simply 1. And then the cos of an angle 45 degrees, the sine of 45 degrees will be the opposite over hypotenuse, so it will be 1 over root 2. And then the cosine of the same angle, it will be adjacent over hypotenuse, which is also 1 over root 2. And then the tangent is the one that will be opposite of hypotenuse, that means 1 over 1, which is simply equal to 1. Now let's consider the solution. The first angle, cos 135 degrees. 135 degrees is found in the second quadrant, and since it is found here, we are going to consider that it will be found by considering 180 degrees to subtract 135 degrees, and this will lead us to 45 degrees. For the second quadrant, it is the sine only that is positive, so the cosine of an angle in the second quadrant is definitely negative. So we are going to consider the fact that this one will be negative here, and then the second one is the angle 30 degrees. So straight away this angle is found in the first quadrant, so the sine of this angle will simply be positive, and then the sine of 135 degrees in the second quadrant, the sine is positive. We are going to consider that this will be a positive number, and then again sine 30 will also be positive. So that's it, this will also be positive here. To rewrite this expression with our knowledge of special angles, we are going to consider the fact that cos 135, which we've said it will be an angle of 45 degrees but then negative, and we've said that cos 45 is 1 over root 2, so we will simply have 1 divided by root 2, and then we are going to subtract. So this is the solution to cos 135, and then the second part here is sine 30 degrees, and we know that sine 30 degrees is a half, so it's positive, but then there's a negative here, we've captured it here, we end up having minus a half, and then divided by sine 135 degrees, which is simply the angle 45 degrees, but then it will be positive. This one here was supposed to be negative, sorry, so this is supposed to be negative cos 45 degrees. So this other one now will be positive, because now the sign is positive in the second quadrant as I've captured here. So we end up having 1 divided by root 2, and then sine 30 degrees here, it will simply be positive. So the sine of 30 degrees is 1 over 2. So I'll have here plus 1 over 2. So in other words, this is what we are expected to solve. So let's begin by rationalizing the denominator. That means we capture its conjugate, which will be 1 over root 2 to subtract 1 over 2. And again, on the numerator, I should be in a position to multiply that 1 over root 2 to subtract 1 over 2. So my next step is to expand. I'll have negative 1 divided by root 2 to multiply this bracket here, which is 1 over root 2 minus 1 over 2, and then minus 1 over 2 to also multiply the second bracket there. Okay, and then on the denominator I'm going to have difference of two squares. That means I'll pick the first term here, and then I square it, 1 over root 2 squared, and then I subtract the second term, and then I also square it like that. And then my next step should be to open the brackets here. I'm going to have by multiplication, I'm going to have negative 1 divided by 2. Since root 2 multiplied by root 2 will give us the number 2, and then to subtract, we are not going to subtract but add, since negative times negative here will be positive, so plus 1 over 2 root 2. Root 2 multiplied by 2 is 2 root 2. And then here we are going to have minus 1, negative times positive is negative, divided by 2 root 2, and then plus 1 divided by 4. And this will be divided by the solution for the difference of two squares here will be 1 over 2 to subtract 1 over 4. The next step will be to consider the fractions that are not SURDS. So I can have negative 1 over 2 plus 1 over 4, and then positive this fraction here minus this fraction here will lead us to 0, divided by 1 over 2 minus 1 over 4. Okay, and so when you add these two fractions, the LCM there is 4, so 4 divided by 2, that is 2 times 1, that is negative 2, and then plus 4 divided by 1 by 4, that is 1 times 1, that is 1, and therefore negative 2 plus 1 is negative 1, so you end up having negative 1 over 4. And then on the denominator there, the LCM is also 4. So 4 divided by 2, that is 2 times 1, which is 2. And then 4 divided by 4, that is 1 times negative 1. You end up with negative 1 here. So therefore, on the denominator here, I'll have 2 minus 1, which is 1. So you end up with positive 1/4. And therefore the last step is to multiply by 4 both on the numerator and the denominator, so that on the denominator side we end up getting 1, and therefore our solution there will be negative 1, and this is the answer. Question 7. Without using a calculator or mathematical tables, express sin 60 degrees divided by 1 minus cos 30 degrees in SURD form and simplify. 3 marks. We are going to consider sin 60 degrees here to be root 3 over 2, and then you're going to divide by 1 minus, and then cos 30 degrees is again root 3 over 2. So this is the expression we need to solve. Solution. So we are going to begin by considering the conjugate of the denominator here, which will simply be 1 plus root 3 divided by 2, which we are going to also multiply on the numerator. This will be root 3 over 2, sorry. And then on the numerator we also do the same. We multiply by 1 plus root 3 over 2. And therefore on the denominator side here, it will lead us to difference of two squares. So you're going to have 1 squared to subtract root 3 over 2 squared. And then on the numerator, we need to open the bracket by multiplying. So this will lead us to root 3 over 2, that means I've multiplied it by 1, and then plus this number multiplied by itself, it will simply be root 3 over 2 squared. So This will end up giving us root 3 over 2 plus root 3 squared is simply 3, and then 2 squared is 4. And then on the denominator, we are going to have 1 squared, which is simply 1, to subtract root 3 squared, which is 3 over 4. So on the numerator side, there is nothing much that you can do to it to remain like that. But then on the denominator, if you have 1 to subtract 3 over 4, it's like having 4 divided by 4 to subtract 3 over 4. We end up having a quarter as our answer. And therefore, to ensure that we have the denominator to be equal to 1, we can decide to multiply by 4, and whatever we do on the denominator, we also do the same on the numerator. So on the denominator side, we'll end up having over 1, and on the numerator side, if I take by 2 1 by 2 2, so here I'll end up having 2 root 3, and then here 4 will cancel. I'll end up having plus 3, and therefore my final answer will simply be 2 root 3 plus 3. The last question that I've considered, question 8. Without using a calculator or mathematical table, simplify. Cos 150 degrees subtract sine 120 degrees, all divided by tan 135 degrees. Considering the unit square for the cos of 150 degrees here, we know that 150 degrees will lie in the second quadrant, but since you are being told it is the cosine of this angle, it is the sine only in the second quadrant that is positive, so the cosine of this angle will be negative. But that angle will simply be 180 degrees to subtract 150 degrees. So this should be the cos of 30 degrees, and this angle here will be negative. And then what about sine 120 degrees? 120 degrees will also lie in the second quadrant, but in this case here, the sine of an angle here in this second quadrant is positive. So we are going to consider that the angle you are looking for is 180 degrees minus 120 degrees, which will simply be 60 degrees, and it is positive. And then the tangent, the tan of 135 degrees, it also lies in the second quadrant, but for this case, the tangent of an angle here is negative. So we are going to consider that it will be 180 degrees to subtract 135 degrees, which will simply be 45 degrees, which will be negative. And then with our knowledge of special angles, we are going to consider that the cos of an angle 30 degrees will be root 3 over 2, but remember it's negative here, so we are going to have negative root 3 over 2, and then to subtract the sine of 120, that means the sine of an angle that is 60 degrees, sine 60 degrees, which will simply be root 3 over 2, and remember it's positive, so it won't affect the positive that is here, which was captured in the question, and then divided by the tan of 45 degrees. We know that the tan of 45 degrees is equal to 1, and since we've captured here that it will be negative, so we end up having negative 1. So this is the expression we need to solve. So the solution here is going to be simple. Maybe let me transfer it here. So this is negative root 3 over 2 to subtract root 3 over 2 and then divided by negative 1. I can begin by first of all multiplying the denominator and the numerator by negative 1 so that I get rid of the negative sign on the denominator. In other words, I'll end up having 1 which cancels the denominator. So I'm left with the numerator to work with. So in other words, I'm multiplying here by negative. It makes this term here positive. So I end up having root 3 over 2, and then negative times negative is also positive here, plus root 3 over 2. Now, since the denominator is common here, I can decide to have it that way, and therefore here I'm going to have 1 root 3. I'm capturing this one so that you see that we are dealing with a coefficient here. So 1 root 3 plus 1 root 3. You end up having, this should be equal to 2 root 3 and then divided by 2. And therefore these 2 will cancel and our solution will be root 3. And this is the answer.